go to angle side postulate. If two angles and the non-included side of one triangle are congruent to the corresponding parts of the another triangle, then the triangles are congruent. In order to use this postulate, it is essential that the congruent sides not be included between the two pairs of congruent angles. If the side is included between the angles, we would actually need to use the ASA postulate. The correct use of the AAS postulate is shown below. So, like this example, the given is angle NER is congruent to angle NVR. Then, RN bisects angle ERV. Then, the proof is triangle ENR is congruent to triangle VNR. Okay, so mauni siya ang triangle. So, di ba ang ato ang i-prove kay ang kaniman siya nga ang triangle ENR kay congruent to VNR. So, first, sa statements kay isuwat first ang given. Sa angle NER is congruent to angle NVR. So, the reason is the given. Next is the RN bisects angle ERV given. So, kaning angle ERN congruent to angle VRN by the definition of angle bisector. So, mao ni siya kaning ERN then VRN. Congruent man sila, di ba? So, mao to definition of angle bisector. So, next is the line RN is congruent to line RN by the reflexive property. Yeah. So, kani siya reflexive. So, reflexive, di ba? Kung unsa siya sa imong kinunhan, equal ra jud siya sa imong sunod. O na siya. Then, ani na ta sa atong last. Sa triangle ENR is congruent to triangle VNR by the ENR of VNR. So, angle side. So, gets
is ASA or angle side angle postulate. If two angles and the included side of a triangle are congruent to two angles and the included side of another triangle, then the two angles are congruent. In a sense, this is basically the opposite of the SAS postulate. The SAS postulate required congruence of two sides in the included angle, whereas the ASA postulate requires two angles and the included side to be congruent. And now let's practice using the ASA postulate to prove congruence between two triangles. And we have the given line PQ parallel line RS and angle PRQ is congruent to angle SQR, and we have to prove that angle PQR is congruent to triangle SRQ by using the ASA postulate. Let's start with this problem by examining the information we have been given. Since segments PQ and RS are parallel, we have to write the statement and write the reason given. And this tells us that we may need to use some of the angle postulates we've studied in the past. Now let's look at the other piece of information we've been given. We know that PRQ is congruent to SQR. Let's further develop our plan of attack. We have been given just one pair of congruent angles, so let's look for another pair that we can prove to be congruent. We can say PQR is congruent to SQR. So that is our second statement, which is the reason is given. And next is angle PQR is congruent to SRQ, and the reason is, and this is by alternative interior angles theorem. And next is line RQ is congruent to line RQ. It is by the reflexive property. And the next is triangle PQR is congruent to triangle SRQ, and that is by the ASA postulate or angle side angle postulate. If two sides and the included angle of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. A key component of this postulate that is easy to get mistaken is that the angle must be formed by the two pairs of congruent corresponding sides of the triangles. If the angles are not formed by the two sides that are congruent and corresponding to the other triangle parts, then we cannot use the SAS postulate. And now, let's use the SAS postulate to prove our claim in this next exercise. Example. Here is our example. And the given is line AC is congruent to EC and BC, and line BC is congruent to DC. And we have to prove that triangle ABC is congruent to a triangle EDC. So, first is we will try to prove that the triangles are congruent by the SAS postulate. We are initially given that segment AC and EC are congruent and that segment BC is congruent to DC. So we have two statements and the reasons are both given. And next is, if we can find a way to prove that ACB and ECD are congruent, we will be able to prove that the triangles are congruent because we will have two corresponding sides that are congruent, as well as congruent included angles. Trying to prove the congruence between any other angles would not allow us to apply the SAS postulate. And now we have the two pairs of corresponding congruent sides, as well as congruent included angles. Applying the SAS postulate proves that ABC, EDC, the two column geometric proof are shown. Angle ACB is congruent to ECD, which is vertical angles theorem. The next is triangle ABC is congruent to triangle ADC, which is the SAS postulate.
The given line JK is congruent to line NK, and the A is the midpoint of JN. Prove that triangle JAK is congruent to triangle NAK. So the only information that we are given that requires no extensive work is that segment JK is congruent to segment NK. We are given the fact that A is the midpoint of JN, but we will have to analyze this information to derive facts that will be useful to us. We only have one pair of corresponding sides that are equal. However, we can say that AK is equal to itself by the reflexive property to give two more corresponding sides of the triangles that are congruent. Finally, we must make something of the fact A is the midpoint of Jn, by definition of the midpoint. So we can conclude that JA is congruent to NA by the definition of midpoint. So now we have three sides of a triangle that are congruent to three sides of another triangle. So by the SSS postulate, we conclude that triangle JAK is congruent to triangle NAK by the SSS postulate.
Hey, hey, oh! Stop. Wait a minute. Fill my cup, put some nigga in it. Take a sip, sign the check. Julio, get the stretch. Right to Harlem, Hollywood, Jackson, Mississippi.